Hello and welcome to Chapter 5. This is the chapter where we get to really look at atoms, individual atoms, and how they all fit together on the periodic table. This is a big deal. This is kind of the basis for all of chemistry. So now that you have a lot of general information about how energy works and the fact that the world is made up of atoms, now we actually get to start looking at them. Okay? Oh, love this font. Okay. Atoms are the smallest form of elements. We're going to spend some time, well, this is going to drive me crazy. Have fun, guys. All matter is made up of atoms. Each element is a different atom, but the atoms themselves, they're made up of all the same things, but when you add one, it's a completely new element, which I think is weird. Each element has its own name and its own symbol, and you can see this on the periodic table. It always starts with a capital letter. If it has a second letter, it's always lowercase. That way when you line them all up in whatever chemical formula they are, you know that if it's a new capital letter, it's a new element. Okay? It doesn't have to have a second lowercase letter. So sometimes they actually use the Latin form of the name instead of the American form because, for instance, lead is not called anything that's even kind of lead in some other languages, so they go with plumbum, which is the original word for lead and in Latin, and so the symbol for lead is capital P lowercase b. Sometimes it can get confusing, but for the most part it's pretty straightforward. So now we're on a structure of an atom. So just to review, an atom is made of 3 types of particles, and I know you've seen this before, but we're going to run through it again. The proton is the positively charged particle in the nucleus, and the neutron is an uncharged particle. It has a neutral charge, which essentially means it has no charge at all. And then you have the electron, and the electron has a negative charge and it orbits around the nucleus. The electrons and the protons never actually touch each other. The protons and the neutrons are together, squished together in the nucleus. So yes, protons and neutrons are bunched together. They have the nucleus is an overall positive charge because all it has is positive and nothing in it. It's the electrons that have the negative charge. In the nucleus, you also have all the weight. Protons and neutrons have essentially the same weight, especially way back when they first tried to figure this out, and they didn't have the sensitive equipment that we do now. That they assigned the weight of a proton and a neutron both as 1. It's got 1, and they're called atomic mass units because they didn't have a unit that was that small. Then you go out to the electrons, and the electrons, they orbit in a spherical shape, so it doesn't go around in a circle. It goes all the way around in a lot of different directions in a sphere around the nucleus, and the electrons hold a negative charge. So in a normal atom, the protons and the electrons are the same number. However many protons you have, that's how many electrons you have, because they have to balance each other out for an overall neutral charge. Though we are going to mess with that a little bit. Electrons have almost no mass, no weight whatsoever. Electrons essentially are little tiny bits of electricity, light, energy, something like that. So, just to get an idea, I'm going to ask you to do something. Draw a circle the size of a penny somewhere in the middle of your paper. Just humor me. Do it. This is going to represent the nucleus of an atom. If we took an atom and made it big enough that the nucleus was this big, then the question is, where do you think the nearest electron would be? Draw where you think the nearest, or point to it or something, to where you think the nearest electron would be if you made the nucleus that big. How close do you think that the first electron would be circling? You have it? It's a trick question. You can't reach that far. It's actually a little more than a mile away. A mile away. There is that much empty space in an atom. So everything that you touch is mostly not there, which I think is totally bizarre. So, okay, back to atom facts. The atomic number is the number of protons in an atom. And when you look at the square on a periodic table that has everything on it, the top number, the biggest number you're going to see is the atomic number, and that is the number of protons. And if you'll notice on a periodic table, they're numbered 1, 2, 3, 4, and they're set up in order if you read them left to right. Each element has a different number of protons, and we haven't, like, there aren't any numbers that are skipped. So really the only difference between hydrogen and helium is that there's an extra proton in there. If I stick one in, it's hydrogen and it's got these properties. But if I stick another one in, I mean, in my mind, that should be twice as big hydrogen. But no, it's helium. It's got a completely different set of properties. It's now something completely different, and the only thing we changed is the number of protons and the number of neutrons. But, you know, I mean, that's it. That's weird. It's weird to me, but that's all it is. The number of protons is what makes the difference. You can change the number of neutrons, you can change the number of electrons, and in fact, in this section, we're going to talk about what happens when you do that. But if you change the number of protons, you completely change the substance. So it all is proton driven. Then we have the atomic mass number. This is the total number of protons plus neutrons, because it's the mass, it's the weight. So how much does a thing weigh? Well, essentially what you do is you count the number of protons and neutrons. So you've got two numbers in your box. You've got the atomic number and the atomic mass. You've got how many protons, and you've got how many protons plus neutrons. So how do you figure out how many neutrons you have? You subtract. That's it. Now, we've gotten to the point where we can more accurately measure the weight of an atom. So it's not just 14 anymore. It's going to be 13.986. And so you're just going to round to 14 because that's going to help you out. So if you're trying to figure out all of the parts of an atom, you look in your box and you say, okay, it's got 6 protons. I'm making this up. I have no idea. It's got 6 protons. It's got a mass of 14. So if I subtract 14 minus 6, I know that there are 8 neutrons. Does that make sense? And if there are 6 protons, you know there are also 6 electrons, because that number always has to be the same unless you're an ion, but we're going to get to that in a second. Okay? The atomic mass number tells the weight of an atom if a proton is 1, remembering that you have to round. Then we get to isotopes. So let's say, we just said if you change the number of protons, then it's a different element. What happens if you change the number of neutrons? That's what an isotope is. It's an atom with a very specific number of protons, so I know exactly what element it is, but a different number of neutrons than you were expecting. For example, here's a chlorine atom. And chlorine has 17 protons, so it's got 17 electrons. But some chlorine atoms have 18 neutrons, and other chlorine atoms have 20 neutrons, and they have slightly different properties, and chemists use them for slightly different things. And so these are called chlorine isotopes. If you just call it chlorine, then you have a very specific number of everything that you're talking about. But chlorine isotopes, we know that, aha, you're talking about one with a different number of neutrons. Okay? Then, if we change the number of electrons, then we form what's called an ion. An ion is an atom with an electrical charge. Now, if we change the number of electrons, you either add one or you take one away. A normal atom usually is neutral because they have the same number of protons and electrons. So the positives and the negatives cancel each other out, and there is no overall charge. However, sometimes an atom will gain or lose an electron. So if an atom ends up with an extra electron and a little negative guy, then it's got a negative charge to it, and we call that an ion. Sometimes an atom will lose an electron, so it's lost a negative, which means it's got more positive now, so now it's a positively charged ion. So if you mess with the number of electrons, you make something with an electrical charge called an ion. And ions attract other ions with opposite charges. So let me give you an example, okay? We're going to start with chlorine. Chlorine, you've already seen it, it's got 17 protons, so it's got 17 electrons. Now, if you look in the outermost shell, there's actually a hole where if its outer electron shell was full, it would have an electron right here. Now, it really wants to fill that spot. It doesn't like not having that spot filled, and the ability for it to steal another electron is really great. It does it really easily. So it's just waiting for some random unsuspecting atom who's got an extra electron just floating around so it can grab it, and it'll pull it in. Now when it pulls it in, it will have an extra electron, which is an extra negative charge. So now it's a chlorine ion with an extra negative charge. Now, there are other types of atoms where in the outer electron shell, they only have 1 or 2 electrons. And when this happens, they've got a bunch of electrons kind of close to the nucleus, but then in this outer sphere, there's only 1 or 2. And so the ability for that atom to hold on to those outer electrons isn't very huge. So these are the guys who, floating around randomly, if somebody can steal their electrons really easily. And so if you're a sodium ion, which is Na, then it's really easy for you to get your 1 outer electron just plucked right out. So now you're missing an electron, which means you're missing a negative charge, which means you have an overall positive charge. Does that make sense? And the cool thing is, if you've got an atom here with a negative charge and an atom here with a positive charge, you've heard the term opposites attract. They actually will connect with each other, and that's a chemical bond. And it's called an ionic bond because it's formed because 2 ions who suddenly they're like magnets, and they're like, oh, now I'm negative and now I'm positive, and now they're sodium chloride and they're table salt. So, ta-da! When you're keeping track of your ions, you need to be able to write them down correctly. So you're going to take the element symbol. For sodium, it's Na. For chlorine, it's Cl. And you're going to add the charge above it to the right side. So my example for you here, we have chlorine, and you can see the little negative sign. That means it's got 1 extra negative charge. Or sodium, which has 1 extra positive charge. Now, just like in algebra, if you have 2 extra or 3 extra charges, then you actually have to put a number. So there are ions that will say +2 or -3 or something like that. Usually it doesn't go higher than 3. Usually it's a 1 or a 2, but they never say +1. It's just a plus or a minus if it's 1, and then 2 or 3 is more than that. You good? Okay. And then we're done. So I will see you next time. I hope this helped, and good luck, and I'll talk to you tomorrow. Take care.